In this lesson, we'll learn about the multiplication rule and how to use it to find the probability of two events happening. For any two events, the probability of A and B happening is going to equal the probability of A happening times the probability of B happening given A has happened. If the two events are independent, then we can just say that the probability of A and B happening equals the probability of A happening times the probability of B happening. Now let's see what this looks like when we're actually doing a problem. A patient is waiting in a waiting room at a doctor's office, and there are several magazines available to look through. 3 of the magazines are about photography, 2 are about cooking, 4 are about wildlife, and 1 is about decorating. What's the probability that if he randomly chooses 2 magazines, that the first one will be about wildlife and the second one will be about decorating? The probability of getting a wildlife magazine first and then a decorating magazine is going to be the probability of getting the wildlife magazine times the probability of getting the decorating magazine, given that you've already gotten the wildlife magazine. Now we're going to need the total number of magazines first before we do anything. So we've got 3 about photography, 2 are about cooking, 4 are about wildlife, and 1 is about decorating. So that gives us 3, 4, 5, 9, 10. 10 magazines total. For the probability of getting a wildlife magazine, we'll put the number of favorable outcomes, which is 4, over the total outcomes, which is 10. And we'll multiply that by the probability of getting the decorating magazine. Given that a wildlife magazine was chosen first, that means there's 1 less magazine for the patient to choose from, so there's a 9 for the denominator, and for the numerator there's 1 decorating magazine available, so that would be a 1 here. Now we could go ahead and reduce the 4/10 to 2/5, and then multiply 2 times 1 is 2, and 5 times 9 is 45. So the answer to this question, what is the probability of getting a wildlife magazine and then choosing a decorating magazine, is 2/45. Now let's take a look at another. There are 26 musicians total in the symphonic band. 10 are boys and 16 are girls. If 2 members are chosen at random, what is the probability that 1 girl and 1 boy will be chosen? The probability of choosing a girl and a boy is going to equal the probability of choosing a girl times the probability of choosing a boy, given that a girl was chosen first. There are 16 girls out of 26 musicians, so the probability of choosing a girl is going to be 16 out of 26. And the probability of choosing a boy, given that you've already chosen a girl, means that there's 1 less student to choose from, so now our denominator is going to be a 25. And let's count the number of boys. All the boys are still left, and there's 10 of them. We could multiply this as is, but it would certainly be easier if we went ahead and reduced these numbers. Let's do 10 and 25. 5 goes into 10 twice, and 5 goes into 25 5 times. And then 16 and 26 could also be reduced. 2 goes into both of these numbers. 2 goes into 16 8 times, and it goes into 26 13 times. So now we've got more manageable numbers. We've got 2 times 8 is 16, and 5 times 13 is 65. So the answer to this question, what is the probability that 1 girl and 1 boy will be chosen, is 16 out of 65. Now let's take a look at a question where the 2 events are independent of each other. There are 20 marbles in a bag, and 7 of them are green. What is the probability that Josh will choose a green marble, put the marble back in the bag, and then again choose a green marble? Since we're dealing with replacement here, the 2 events are going to be independent of each other. So we can use this equation. The probability of getting a green marble and getting another green marble equals the probability of getting a green marble times the probability of getting another green marble. The probability of getting a green marble the first time is going to be 7 out of 20. And then since the marble is being put back in the bag, the probability of drawing another green marble is exactly the same, another 7 out of 20. And we can just multiply these 2 values together to answer this question. 7 sevens are 49, and 20 times 20 is 400. So the answer to this question, what is the probability of getting a green marble and then getting another green marble, is going to be 49 out of 400. Let's take a look at one more problem, and this time we'll use some algebra to find the probability. There are 4 colors to choose from in a bag of 24 marbles. If the probability of event A and B happening equals 1/23rd, and the probability of B happening given A equals 3/23, which of the following could be event A? Now we don't know if event A is drawing a yellow, a green, a red, or a blue marble, but I think we can figure it out using our formula and the two numbers that we have for events A and B. We know that the probability of A and B equals the probability of A times the probability of B given A. With a little manipulation, we can isolate the probability of A to get the probability of A equals the probability of A and B happening divided by the probability of B given A. Now let's see which numbers we have. We have the probability of A and B is going to be 1/23rd, and the probability of B given A is 3/23. And we're getting that from up here, right inside the problem it was given to us. This gives us 1/23rd divided by 3/23, or 1/23rd times 23/3. And if we want to reduce the 23's ahead of time, that gives us 1 times 1 is 1, and 3 times 1 is 3. If we check our answers over here on the left, the only event that happens that gives a probability of 1/3 is going to be the probability of drawing a red marble. So event A is drawing a red marble, and the probability of getting a red marble is 1/3. Now you know a bit more about the multiplication rule and how to use it to find probabilities. See you next time!